Hello. In this little exploration, we're going to look at something called a parallelogram. Okay. In the next video, you'll see we'll get a formal definition for parallelogram, but really its formal definition is a quadrilateral, meaning four-sided figures, okay, with both pairs of opposite sides parallel. Okay. Okay, so it's a parallelogram is a quadrilateral, so four-sided figure, with both pairs of opposite sides parallel. And so we're going to look at this parallelogram and talk about parts and pieces of it. But first, let's go through the process on how to make a parallelogram using Geogebra. Okay, so first I'm going to start with here a point A, and then I'm going to draw a line through A. So we draw a line, and let's take it over here to point B. Okay, so now I'm going to create a parallel line to AB down here. So to get that parallel line, I'm going to need a point C down here. Okay, so I started out with a line with the 2 points on it and this point C. So now I'm going to do a parallel line. So up here, if we click on this fourth one over, the second option down, parallel line. And if you see down there at the bottom, it says select point and parallel line. Select point and parallel line. So we'll select our point and the line, and there we have, if we move these points around, as these points in this line move, so does the other one, and as this point moves, you see it will always stay parallel to AB. Okay, so now we have, let's say, what we'll call the top and bottom of this parallelogram. Okay, so now we need to create the other two sides. So I'm going to take a line and I'm going to connect B and C. So now I need another parallel over here. Okay, so to do that, again, I'm going to hit the fourth one over here. I want a parallel line. I want it to go through A, but be parallel to this side here. So there, if you notice, as I move these points around, this line will always be parallel to this one, and this line will always be parallel to that one. And you can see our quadrilateral inside here. But we have a few extra lines, so I'm going to come in and I'm going to put a point right here at this intersection, and now I'm going to create a polygon, okay, that connects A, B, C, D, and goes back to A. So now I have that polygon there, so it gives me those side lengths, and it will actually give me those side lengths over here. Okay, but now I'm going to get rid of all these extra lines. So I'm going to come over here, I'm going to find my lines. So here was my first line, let's click that, get rid of that. Do you see the points still remain even though you don't see the line? And I'm not getting rid of them, I'm just hiding them. By clicking on this, it hides it. So there, I've now hidden all four of my lines. Okay, but now if you notice, as I move these points around, this will, move. Okay, as I move these points around, this thing will always stay parallel. This top line A and C will always be parallel, and side B and side D will always be parallel. Okay, so as we move around. Okay, so as I move these around, you see we're always parallel, parallel, parallel all the time. So no matter what I do to these, I get parallel. So each of these is a parallelogram. That's a parallelogram. It's a parallelogram. All of these are always parallelograms. Okay, parallelogram. Still a parallelogram. Yep, that's still a parallelogram. Okay, so it will always be a parallelogram. Okay, so now let's go ahead and let's look at the sides. So I'm going to go ahead and do distance or length. Let's do this side. This side is 11.15. Side B is 4.93. C is 11.15. And D is 4.93. Anybody notice anything about these? Okay. And even as I move these points around, anybody notice anything? Okay, if you notice something, go ahead and jot that down. Your notes, we'll look at the theorem there. Okay, I'm going to kind of point it out. Look at A and C. And then what about B and D, lowercase b and D? Segment D, segment B. Okay, what's going on there? Anybody notice something? Okay, that's kind of interesting. So looking at those sides, we notice a bit of something going on. Even as B, if we get really fat or really, really little skinny, you can still see 5.48, 5.48, 5.23, 5.23. That's kind of interesting. Okay, now let's go ahead and let's look at the angles. Okay, so let's measure these angles. So let's go ahead and let's measure angle A here. So we'll have to go up B, make sure I'm going the right way. Angle A, okay. Angle B, angle C, and angle D. Okay, let's move those so we can see them a little better. Let's move them on the outside there. They're not in the way. Okay, anybody notice anything about these angles? That's kind of interesting as well. Did we just get lucky and pick the one parallelogram that works in? Nope, because as I switch them around, well, let's look. 64, 64, 116, 116. Well, let's move this over here. 120.67, 120.67. Okay, so that leads us into some of our properties of parallelograms. We'll discuss more of those properties in the next video.